This video's subject is, can we go to Saturn with the present technology? Well, saying is easy, but we learn the physics, so we use the physics to examine, see if it's possible to go to Saturn with the present technology. First, we have to check energy to go against the sun's gravity. Usually we don't consider sun's gravity because traveling time to the moon, for example, is too short, and sun's gravity potential difference is not that much. It's not in the equation. Usually we have energy necessary to go against the Earth's gravity. So when you go to the moon, the Earth's gravity is the only issue because distance is so short, and the Earth to moon, what's happened is satellite need to accelerate up to say Mach 20. Then around the moon gravity is gonna pull. Okay, the Saturn is way far, so you have to keep accelerating all the way to the Saturn until you see Saturn's gravity kicks in. Okay, so we calculate this using the physics we learned. The potential energy equation, Gm over R. Okay, R is Earth, 148 million kilometers away from Sun, and Saturn is 1.2 billion kilometers away from Sun. So gravity constant and the Sun's the mass, we calculate we need energy about huge energy, 7.86 times 10 to the 9th. This much joules of energy is necessary per kilogram to bring it to the Saturn. Let's calculate the escape energy from Earth to the Saturn. This gravity constant is same, but this is Earth's mass. Gravity is much smaller, so only 10 to the 3rd joules. So compare with this, the escaping from Earth is nothing. Escaping from Sun's gravity is a major factor. This escape from Sun's gravity. So that's gonna be the major factor to go to Saturn. Okay, so launching satellite to the Earth's orbit is small portion of energy. The major portion of energy is to escape from Sun's gravity for that kind of distance. So what happened is the energy we need against the Sun's gravity is far more than the escape energy. So there is a reason why comet cannot escape from the solar system. Comet come to the Sun at very fast speed and go around the Sun and go back to the way probably edge to edge of the solar system, but eventually slow down because of the Sun's gravity and come back to the Sun. It's always pulled by the Sun's gravity. Okay, so don't think that once you fly in the space, well, Newton's first law, you keep going at the same speed. That's not gonna happen within solar system. Okay, if you are going circling around the orbit, okay, then centripetal force is gonna cancel out the gravity, so you become microgravity. Then anything keep moving, just like Newton's first law. But when you are going to Saturn, it's not going to happen. You are always pulled back by Sun's gravity, so you need to keep using rocket engine to accelerate to go against the Sun's gravity. Okay, so escape velocity is initial velocity to reach to the destination. So if you have Mach 367 on Earth, then you may reach to Saturn. Okay, but think realistically. Launching a probe to 100 kilometers, 100,000 kilometers, kilometers, the satellite, is a big deal for human technology, and that's only Mach 5. Now, when we send a probe to Moon, we use engine to accelerate to Mach 20. Okay, and that fuel has to be launched to the orbit first, and that's a big deal right now. We're talking about Mach 367. Okay, so 20 times more speed we need. Energy wise, it's a square of speed, so square of that much difference is the energy you need. And as you know, in order to carry the huge fuel tank, you need even more energy to launch it. Okay, this is like you're driving from New York to San Francisco without purchasing any gas on the way. There's no gas station on the way to Saturn, right? So what's happened is 3,000 miles using 20 miles per gallon, we need to carry 150 gallons. So about, its fuel tank is 15 gallons. We need to have a 10 times bigger tank we have to carry. But if you carry that much, we can't go even 15 gallon. We can't go 20 miles per gallon. Probably it's going to drop to 15 miles per gallon. That means we need even more gas, say 250 gallon. So we have to carry more fuel, means the gas mileage is worse. That means you have to carry more gas. Okay, so that's a kind of situation we have here. How much we can launch to an orbit, it's called launching payload. Payload is probably right now, no matter how big the rocket is, 50 tons. That's probably not enough fuel to bring it to the journey to the Saturn. So I would say it's impossible to go to Saturn with the present human technology. Well, it's depressing that human cannot go to even Saturn. Well, yeah, it looks like the current technology. And also you have to think about how the trajectory to go to Saturn. You're not going straight to Saturn. Nothing is stationary. The Earth is moving. So you go to the Earth orbit first and increase orbit size multiple times, then depart orbit. Here you need to start burning the first stage of the fuel. Okay, and if you run out of a fuel, what happens is it's go back to sun, like that. Okay, so it's fail, just like a rocket going to Earth orbit sometimes fail because didn't reach enough speed to get onto the orbit. Same thing, it's failed to get onto the orbit of sun, so it's going to be pulled back to the sun and burn. That's it. Okay, so you have to keep burning how many years? 10 years, 20 years, and separate the second fuel tank because it's heavy. Okay, then keep burning and third fuel tank, and finally go to Saturn. So fuel tank separation, multiple stages of fuel tank separation will be necessary. Without additional fuel, definitely you're going to fail because it's going to pull back to sun. Another big issue is navigation system. Do we have a navigation system? What is navigation system? Navigation system is a system to determine where you are in the space. Here, how do you determine your location and the speed? Okay, that technology doesn't exist right now. What probe, when we send a probe to moon, we just make a guess. It's fly this direction at this speed, then it's supposed to arrive on the moon. That's short distance. We're talking about 1.2 billion miles. Okay, so it's easily get lost. It's like you're leaving San Francisco with a small boat and hope you reach to Guam without navigation system. It's never happened. Okay, probability is less than 1%. Okay, the same thing if you go to Saturn without proper navigation system, the chance you reach to Saturn is less than 1%. It's never happened because slight error in the speed or angles, the Saturn is moving, okay, supersonic speed around the sun. So if you miss it, Saturn's gone, or if you go too early, Saturn hasn't come yet. So what do? You sit and wait? You can't do that, right? So you have to properly get into the Saturn's orbit at the proper speed. That's a tremendous work. Okay, it's not gonna be easy if we cannot even do for moon. Okay, how many times we succeeded going around the moon? Well, don't talk about 50 years ago. The recently, nothing. Okay, so we don't have navigation system, and we don't have enough payload to launch such a big fuel tank for the probe. You know, when you see the picture of the probe, it's just like antenna in the little box. Okay, that won't fly. We need a huge fuel tank and need to have a multiple stage to have such a journey against sun's gravity. So I will say no, we don't have a technology to go to Saturn. Too bad to hear that, but at least we can go to the very close one like moon and probably Mars. But beyond that, it's going to be challenge, real challenge. Okay, if somebody shows very nice CGI, okay, that's a CGI. It's not real engineering. You learn physics, you know how to evaluate. You can tell what is possible, what is not possible. I hope you enjoy listening this video. Please check out the video too. And if you like, click subscribe.